Today we're doing section 10.1, comparing two proportions, P1 minus P2. Describe the sampling distribution of P hat 1 minus P hat 2. Remember when we describe distributions we use SOX, okay? Shape, outlier, center, spread. Well, in this case, the sampling distribution, we're not going to be looking for outliers. There shouldn't be any outliers, but we're going to look at the shape, center, and spread. The shape is approximately normal as long as N1 times P1, N1 times 1 minus P1, N2 times P2, and N2 times 1 minus P2 are all greater than or equal to 10. The center is P1 minus P2, and the spread is the square root of P1 times 1 minus P1 divided by N1 plus P2 times 1 minus P2 divided by N2, as long as 10 times N is less than or equal to the population for both. The 10% rule has to apply. All right, confidence intervals for P1, P2, P1 minus P2. All right, the conditions, same as one proportion. You just have to check the conditions for both samples, so you have to double it. Formula for a two-sample Z interval, it's parentheses, P hat 1 minus P hat 2, close parentheses, plus or minus Z star times the square root of P hat 1 times 1 minus P hat 1 over N1, plus P hat 2 times 1 minus P hat 2 over N2. The calculator steps. How do we do this in the calculator? Because we don't want to have to remember that formula, and we certainly don't want to have to write it out and substitute all the numbers in there. So the calculator, we go menu, statistics, that should be familiar by now. Menu, statistics, confidence intervals, and we're going to choose 2 prop Z interval because we're doing a 2 sample proportion. So 2 prop Z interval. All right, let's do an example. All right, many news organizations conduct polls asking adults in the United States if they approve of the job their president is doing. How did President Obama's approval rating change from August 2009 to September 2010? According to a CNN poll of 1,024 randomly selected U.S. adults on September 1st through 2nd of 2010, 50% approved of Obama's job performance. A CNN poll of 1,010 randomly selected U.S. adults on August 28th through 30th of 2009 showed that 53% approved of Obama's job performance. Use the results of these polls to construct and interpret a 90% confidence interval for the change in Obama's approval rating among all U.S. adults. Okay, so state, plan, do, conclude. That's what we're going to do. State. We want to estimate P 2010 minus P 2009. All right, 2 things here. First, it's P1 minus P2 because we're doing the change. We're doing a difference. Okay? All right? Notice it's P's of 2010 and P's of 2009. You can do it like that, or you can call them P1 and P2. As long as you label, as long as you define what you're using, it doesn't matter how you write them. Okay? All right, so here we go. Where P equals the true proportion of all U.S. adults who approved of Obama's job performance in September 2010 and August of 2009. So we're defining the parameter. And again, we're calling it P's of 2010 and P's of 2009 because that's what they represent. But I could call them P1 and P2 and just define one is for the year 2010 and one is for the year 2009. All right, so plan. We will use a 2 proportion Z interval for P 2010 minus P 2009 if conditions are met. Same conditions, check the random. Stated, 10%. We assume 10 times 1024 equals 10,240 is less than or equal to residents or all adults in 2010. And 10 times 1,010 equals 10,100 is less than or equal to U.S. adults in 2009. Notice we have to do 10% for both samples. Normal. 0.5 times 1024 is 512. 0.5 times 1024 is 512. 0.53 times 1010 is 535. 1 minus 0.53 times 1010 is 475, and they're all greater than or equal to 10. Notice you have to check it for both samples. All right, now it's time to do the do step. So go to your calculator, go to a calculator page, go menu, statistics, confidence intervals, 2 prop Z interval, and the first thing they ask you for is successes. And that would be the 512, That would be from the 0.5 times 1024, so that would be the 512. And the sample size would be 1024. Then ask for successes for x sub 2, so that would be the 535. And the n would be the 1010. And the confidence level was 0.9. And you should get the interval of negative 0.0661 to 0.00674. So let's conclude. We are 90% confident that the interval from negative 0.0661 to 0.00674 captures what? Captures the change in proportion of U.S. adults who approve of Obama's job performance from August 2009 to September 2010. Okay? So that's two sample confidence interval for proportions. All right, based on your interval, is there convincing evidence that Obama's job performance rating or job approval rating has changed? Okay? Well, consider this. What if there is no difference? What if there is no change? What would that look like? What number would that be? That would be the number 0. Is 0 within my interval? Yes, 0 is between negative 0.0661 and 0.00674. So since 0 is included in the interval, it is possible there had been no change in this approval rating. Therefore, we do not have convincing evidence that his approval rating has changed. All right, significance test for P1 minus P2. Conditions. Conditions are the same as one proportion. Just check them for both samples. Test statistic for a two-sample z-test for P1 minus P2. Z equals parentheses P hat 1 minus P hat 2, close parentheses, minus 0, divided by the square root of P hat C times 1 minus P hat C divided by N1 plus P hat C times 1 minus P hat C over N2, where P hat C is equal to X1 plus X2 divided by N1 plus N2. Now again, that's just a nasty little formula. Don't really want to have to memorize it. Don't really want to have to substitute numbers into it and type it in my calculator. I'd rather just use the calculator to get it all done. So the calculator steps: menu, statistics, stat test, 2-prop z-test. Okay? Now, when it comes to writing the hypotheses, there are two ways to write the hypothesis. The null hypothesis will always be P1 minus P2 equals 0, because the null hypothesis is a statement of no difference, and no difference means 0. But another way I could write it is P1 equals P2. My alternatives can be P1 minus P2 is greater than 0, or P1 is greater than P2. My alternative could be P1 minus P2 is less than 0, or I could write it as P1 is less than P2, or my alternative could be P1 minus P2 is not equal to 0, and another way to write it is P1 is not equal to P2. Is there an advantage to writing it one way over the other? Not really. I prefer writing it the way on the right, simply because the way the alternative is written on the right is the way you're going to see it in your calculator. Other than that, they're exactly the same thing. Okay? All right, let's do an example. Are teenagers going deaf? In a study of 3,000 randomly selected teenagers in 1988 through 1994, 15% showed some hearing loss. In a similar study of 1,800 teenagers in 2005 to 2006, 19.5% showed some hearing loss. Do these data give convincing evidence that the proportion of all teens with hearing loss has increased? Okay, so here we go. Let P1 equal the true proportion of all teenagers with hearing loss in 2005 to 2006, and P2 equal the true proportion of all teenagers with hearing loss in 1988 through 1994. Here we're using P1 and P2 because I have a range of years, not just 1 year, like I did in the last example. So I'm using P1 and P2. Okay? We will test the following hypotheses at the alpha equals 0.05 significance level. So what are my two hypotheses? Well, the null hypothesis is always a statement of no difference, so P1 equals P2. And in this question it says, is there evidence that it has increased? So we're going to say P1 greater than P2. So now we're going to plan. That was my state. Now it's time to plan. We will perform a 2-sample z-test for P1 minus P2 if conditions are met. First condition is random. It's stated that they come from random sample. Second condition is 10%. We assume 10 times 1,800 equals 18,000 is less than or equal to the number of teenagers in 2005 to 2006. We assume 10 times 3,000 equals 30,000 is less than or equal to the number of teenagers in 1988 through 1994. Okay, normal. 0.15 times 3,000 is 450. 1 minus 0.15 times 3,000 is 2,550. 0.195 times 1,800 is 351. 1 minus 0.195 times 1,800 is 1,449. Okay, and they're all greater than or equal to 10. All right, so now comes the do step. For the do step, we're going to go to the calculator. We're going to go menu, statistics, stat test, 2-prop z-test, number 6. It asks for successes for x1, so that's going to be the 450. And, no, I'm sorry, that's going to be the 351 and the 1,800 for your N1. And then your x of 2 is going to be your 450. And your N2 is going to be 3,000. And the alternative is greater than. And when you do that, you get your Z is 4.05. And your p-value is approximately 0. It's 0.000026, which is approximately 0. So now it's time to conclude. Since the p-value is less than alpha, we reject H sub O. There is convincing evidence. Convincing evidence of what? Go back to the question. That the proportion of all teens with hearing loss has increased from 1988 to 1994 to 2005-2006. Okay? All right. Last example. This last example is on here only to show you about the language of making hypotheses for experiments. Okay? It's conducting another test, which we just did, so you know how to conduct the significance test. It's strictly to show you how to write the hypothesis when we're talking about an experiment. In an effort to reduce healthcare costs, General Motors sponsored a study to help employees stop smoking. In the study, half of the subjects were randomly assigned to receive up to $750 for quitting smoking for a year, while the other half were simply encouraged to use traditional methods to stop smoking. None of the 878 volunteers knew that there was a financial incentive when they signed up. At the end of 1 year, 15% of those in the financial rewards group had quit smoking, while only 5% in the traditional group had quit smoking. Do the results of this study give convincing evidence that a financial incentive helps people quit smoking? Okay? All right, so the state. Let P1 equal a true quitting rate for employees like these who get a financial incentive to quit smoking, and P2 equals a true quitting rate for employees like these who don't get a financial incentive to quit smoking. Notice it says like these, and notice it's in present tense. Okay? Please make sure when you're doing experiments, you put like these, and you do it in present tense, no past tense. If you use past tense, you're going to get it wrong. All right? And then it says we will test the following hypotheses at the alpha equals 0.05 significance level. The null hypothesis, P1 equals P2. The alternative, P1 is greater than P2. Plan, we will perform a 2-proportion z-test if conditions are met. Random, treatments were randomly assigned. Independent, remember the 10%, we're not sampling, so we don't need to check that. For normal, there's your conditions checked for normal. They're all greater than or equal to 10. The do step gives you 4.94, which is approximately 0. Since the p-value is less than alpha, we reject H sub O. There is convincing evidence that financial incentives help employees like these quit smoking. Again, notice like these in present tense.